Hello everyone, this is Dr. Sharmila Pandey from School of Sciences, Sage University, Bhopal. Today I will discuss about the conformation of alkane. So conformational isomer or conformation of ethane. Conformation, what is conformation? The different arrangements of atoms that result from rotation about a single bond. Like here we can see, if we rotate the single bond, the CC single bond, then the different arrangements we will get are the conformations. What are the conformers? A specific conformation, that is conformational isomer. So these are their same connection of atoms. So atoms connectivity will be the same, but we will get a different molecule only by the rotation of this carbon-carbon single bond. So as we already previously discussed, this is the sawhorse representation and this is the Newman projection, where the front carbon is this the represented as the dot and the back carbon as the circle. So here we can see this is where the bond, this hydrogen atom from the front carbon and the hydrogen atom of the back carbon, the angle between these two is 60 degree, and so this will be known as staggered conformation. If we rotate this by 60 degree, so this hydrogen will come here and the other will come here and this will come here. So at that time they will be parallel to each other, that is the angle between these two hydrogen atoms is 0. So in this case there will be a rotational barrier. Because of this eclipse conformation, there will be energy barrier, that is 4 kilojoule per mole for each hydrogen eclipsed situation. So in this case we can see there are 3 hydrogen eclipsed. So here the rotational barrier will be 4 plus 4 plus 4 equals to 12 kilojoule per mole. So 12 kilojoule per mole of extra energy present in the eclipsed conformation of ethane, and this is called torsional strain. So we can see this one is less stable compared to the staggered conformation. So what is torsional strain? Torsional strain is there due to repulsion between the electron clouds in these CH bonds as they pass close by each other in the eclipsed conformer. So here we can see for hydrogen the rotational barrier is 4 kilojoule, for 3 it is 12 kilojoule per mole. So that this is the torsional strain, and that is why compared to staggered conformation, eclipsed conformation is less stable. Now, if we see a graph of potential energy versus bond rotation in ethane, here the two colors are used. For one is red, which is in the front carbon, the one is blue, which is in the rear carbon, attached to the rear carbon. So in this case, we can see the angle is 0 degree. Here, if we rotate by 60 degree, so in this case, that 12 kilojoule per mole rotational strain is present. In this case, there is no rotational strain. So here the energy is here. So this energy gap is 12 kilojoule per mole. In this case, that torsional strain is present. Here the torsional strain is not there. Again, if we rotate it by 60 degree, again we can see this kind of eclipsed conformation will be obtained. So if we rotate this one by 120 degree or this one by 120 degree, again the 12 kilojoule per mole torsional strain will be there. Again for 180 degree from here or 60 degree from here, we can see these are anti, so 0 torsional strain. At 240 degree, again these eclipsed conformation has been arised, so the torsional strain is 240 degree. When 300 degree, there is 0, there is no such torsional strain. And at 360 degree, that is when again they are in the eclipsed position, this 12 kilojoule per mole torsional strain is there. Now, if we go to propane, in propane there is one methyl group is present. So let us consider the methyl group is present in the front carbon. Again, this conformation is staggered conformation. If we rotate by 60 degree, we will get eclipsed conformation. So hydrogen eclipsed 4 kilojoule. Here also hydrogen eclipsed 4 kilojoule rotational barrier. But when the hydrogen is eclipsed with a methyl group, the rotational barrier is now more, so it is 6 kilojoule. So in this case, we can see the torsional strain is 6 plus 4 plus 4 equals to 14 kilojoule per mole. If we now come to butane, in butane there are two methyl groups. This is the anti conformation where the two methyl groups are completely anti-parallel. Here, Gauge conformation where two methyl groups are at 60 degree angle. So anti-conformation, two large groups are in the opposite side, and Gauge conformation, two large groups are at 60 degree apart. Now in this case, so the situations can be in eclipsed conformation, it can be eclipsed with hydrogen, it can be eclipsed with both the methyl groups. So when one methyl group is eclipsed with hydrogen, as in case of propane, we have seen the torsional strain here is the 6. Here also the rotational barrier will be 6, and for hydrogen it is 4. So for eclipsed conformation, we can see like this kind of eclipse, when methyl is eclipsed with hydrogen, the total cost is 16 kilojoule per mole, 6 plus 6 plus 4. When it is eclipsed by both the methyl groups, so if both the methyl groups are eclipsed, the rotational barrier will be 11 kilojoule per mole. For hydrogen it is again 4, and here also hydrogen it is 4. So 4 plus 4 plus 11. So it will be, the total cost will be 19 kilojoule. So because of these are methyl groups, in Gauge conformation also, there will be a little bit of torsional strain. The amount is 3.8 kilojoule. So like previously, as we have seen, one methyl, one hydrogen, or even both hydrogen, the rotational barrier is 0 in Gauge conformation. But for butane, because of the presence of these methyl groups, the hydrogens are there. So here will be also some rotational barrier, and the amount is 3.8 kilojoule. The steric strain is repulsive interaction that occurs when atoms are too closer. Now we have seen there are 4 possible conformations of normal butane. 2 are staggered, in which one is anti, where both the methyl groups are at 180 degree angle, and Gauge, here the methyl groups are at 60 degree angle. Along with that, there are 2 types of eclipsed conformation possible. One where methyl groups are eclipsed with hydrogen. The other one when both the methyl groups are eclipsed with each other. So now if we come to the graph of potential energy versus bond rotation in butane, we can see when they are anti, so there is like this, we can consider 0 torsional strain. When they are eclipsed, here we have already counted 6 plus 6 plus 4, that is 16 kilojoule per mole. In staggered, in the other cases, although it was 0, but in this particular case, it will not be 0 because there will be some 3.8 kilojoule of rotational barrier because of the closeness of these two methyl groups. These are bigger groups. When the methyl groups are eclipsed by each other, we have seen this is 11 plus 4 plus 4 equals to 19 kilojoules. So this is the least stable conformation. Again, when it is 60 degree, there will be 3.8 kilojoule per mole rotational barrier. When the next conformation after 60 degree rotation will be the eclipsed, where hydrogen are eclipsed with methyl again, so the energy will be 16 kilojoule per mole. And when again after that, if it is 180 degree, so both the methyl groups are anti, that time the torsional strain will be again 0. So here we can see these are the most stable conformation. These eclipsed, where methyl are eclipsed with each other, is the least stable, and then comes the then comes this eclipsed, where methyl is eclipsed with hydrogen, these two, and after that will be this gauge conformation, where these methyl groups are at 60 degree. So we have seen this one is most stable, this one is least stable. Again, this one stability is more than compared to this, because here it is only 3.8, and in this case it will be 6 plus 6 plus 4, that is 16. So the here it is 0, 3.8, then 16, and here it is 19. So this is the most stable. After that will be this one, next stability order, this one, and this eclipsed, where methyl groups are eclipsed with each other, is the least stable conformer. So that is what is mentioned here. If it is hydrogen, hydrogen, it will be 4. Hydrogen CH3, it will be 6. Methyl, methyl will be 11. All these are for eclipsed. And in this case, the CH3, CH3 are in the in steric strain, and so the amount is 3.8 kilojoule. So we can see here it was torsional strain, here mostly torsional strain. For this one, torsional as well as steric strain, because both are very big groups. In gauge conformation, this is only the steric strain. So this was the energy cost for interactions in alkane conformers. Thank you.